Hello, gentlemen. I hope everyone's doing well. Welcome to our first online lesson. Today we're going to be reviewing 9.3 and 9.4. This is going back to trigonometry, looking at law of sines, law of cosines, area of triangle formulas, as well as trig identities, which is what we were just starting to do before the break. Because it's been 3.5 weeks or so since we've done any of this, I'd like to take this next 14 minutes or so to offer a review of 9.3 and 9.4. This will not serve as a complete lesson for these two subtopics, but hopefully it will refresh your memory of what we went over and what law of cosines and the law of sines are, when they're used, and importantly in 9.3 as well, what the ambiguous case is. So this is when we can possibly have either no triangles or two triangles when we're given three specific pieces of information about a triangle. Okay, so we're going to start on page 484. This is 9.3. I encourage you to follow along. And we're actually not going to start with the area of the triangle. We're going to skip ahead just as we did in class. And we're first going to talk about the law of sines. And so the law of sines is a formula that can be used when you have an AAS, an ASA, or an SSA triangle case. So an angle, angle, side, angle, or side angle. And the idea is you're only using two of these ratios of the proportion in order to solve for an unknown. So let's see, this is my first time doing it, but it should allow me to draw. And so if we take a look at this left-hand side proportion, if we are solving for A, then perhaps we'll only use these two ratios. If we're solving for C, perhaps we'll only use these two, right? So despite the fact that there are two equal signs and three ratios here, we're really only using two in order to figure out one unknown. That unknown could be angle A. It could be side A, which would be the angle opposite angle B. It could be angle B, it could be angle C, or it could be sides B or C. Remember, however, that we label our triangle as having lowercase side A always across from angle A, angle B across from side C, and angle C across from side C. So the angle, which is an uppercase letter, is always opposite the side of the same letter with a lowercase letter. Okay. And so there's some examples of law of sines here. This is example 3 in the textbook. So in example 3a, we see a side angle triangle. For example, 3b, we see an angle side angle triangle. And so we're solving for different variables, but we use the law of sines the same way. So I encourage you to look back specifically at example 3 and see how law of sines are used. This is also important because law of sines does come back into play in 9.4 as a way to more easily finish solving a triangle after the use of law of sines. Now, you may remember we had a lesson as well as a worksheet that I gave you on what we call the ambiguous case. And there's some good how-to videos out there. If you search trigonometry ambiguous case or side angle ambiguous case, the idea is that if we have two sides of a triangle next to each other, and we have an angle that is not the angle in between them, then it's possible we can have one triangle from those measurements, two triangles from those measurements, or zero triangles from those measurements. And so examples 4, 5, and 6 show us those three possibilities of having one possible triangle, one solution, zero solutions, or two solutions. And just quickly to recap here, the idea is to use the law of sines in order to find the unknown. And in this case, our unknown is going to be angle B, which turns out to be 29.9 degrees. Okay? To figure out what our remaining unknown angle is, we start off knowing angle A. So if we find B is 29.9, our unknown is angle C. We simply take 180 minus our known angle, 115, plus our newly found angle, 29.9, and we get our final angle, which is 35.1. Great. So we use that value of 35.1 to find the missing side, and we're done. Now, if we were to take 180 degrees and subtract 115 and subtract 180 minus 29.9, which would be the other angle in the unit circle that would give us, that would have the same value for the sine of angle B, then we would find the angle measure is above 180 degrees for the entire triangle, so it doesn't work out. We know that all angles have to add up to 180 degrees. That doesn't make sense. We'll see that in just a minute. Then we have the possibility of no solution. So this is example 5. This is a side-side angle case with no solution. And so when you try to solve this using law of sines in your calculator, it shows you an error. And if it shows you an error, it's because you get a sine value for an angle that cannot exist. Okay, so that's really the easiest one. And then finally, we have the case with two solutions. So in this case, we are solving, here we go. So we are solving triangle ABC when A is 40 degrees, side A is 13, and side B is 16. And it ends up that these are the two possible triangles we can get, because when we derive the sine of B using our calculator, we end up getting an angle which is 52.3 degrees. Well, 180 minus 52.3 degrees is 127.7 degrees. 127.7 plus the original angle we're given, angle A, adds up to less than 180 degrees, which means we can have two separate triangles. We can have the obtuse triangle here, and then we can have the even more dramatically obtuse triangle here. So that is the ambiguous case. Now, quickly going back, the last thing that we went over in 9.3 was actually the first part of 9.3, which doesn't fit in quite as neatly with the rest of all of this, and that is the area of a triangle. So if we're dealing with the area of a right triangle, that's no problem. Or if we're dealing with an area of a triangle where we know the height, that's not a problem. But if we're dealing with the area of a triangle where it is not a right triangle, and we don't know all of that information, so for example, we know two sides and an angle, we can use the following formulas. So these are really all the same formula. It's just we use whichever one is appropriate for the angle that we're given. The first one we would use if we were given angle A and sides B and C. The second one we would use if we were given angle B and sides A and C. And the third one we would use if we were given angle C and sides A and B. Again, I encourage you to look over the pertinent example, that's example 2, in order to review the area of triangles. Now, moving on to 9.4 with the little bit of time we have left. 9.4 was the law of cosines. And so here we go on page 494. This is the law of cosines. And this looks similar to the law of sines in that we're given more information than we can use all at once. It also maybe looks a little bit more like the area of a triangle formulas from the last section. The idea is, depending what information we're given, we will use the appropriate one of these three equations. So depending on whether we are given angle A, angle B, or angle C, we will use the first equation, second equation, or third equation, respectively, in order to find our at least one of our missing sides. And so there are both the SAS case and the SSS case where we use law of cosine. So if you'll remember, for any other three pieces of information we know for a non-right triangle, we can use the law of sines. But if it happens to be the SAS or the SSS case, the law of sines does not give us enough information. We'll have two unknowns for a proportion instead of one unknown. And so law of cosine allows us to get that last critical piece of information that will then allow us to use law of sines to more easily calculate any other missing parts of that triangle. Remember, solving a triangle means to find all three angles and all three sides. So in this case, if we tried the law of sines, it wouldn't work. If we put sine of 34 degrees over B equals sine of A over 11, that's not going to be enough information, right? We're going to have two unknowns. We're going to have both angle A as an unknown and side B. And it would be the same if we tried sine of 34 over B is equal to sine of C over 14. Again, we have two unknowns. So in this case, what we have to do is recognize that since we have angle B, we're going to use the second equation where we take the cosine of that angle, multiply it by 2 times side A times C, and subtract that from A squared plus C squared. When we do that, we take the square root, and then we get B. And so example 1 is simply working through that math in order to figure out what side B is. Once we find side B, we could use law of cosines to find remaining values, but it's quite a bit easier to set up a simple law of sines proportion in order to figure out the remaining unknowns of our triangle, and that's what's been done here. And the next example is doing the same thing using the law of cosines. With the law of cosines, it helps if you start off by choosing the equation that uses your largest angle. Okay? And if you're not sure what your largest angle is always going to be opposite your largest side. This ensures that if it is an obtuse triangle, that the two angles that you're finding are going to be your that the two angles you're going to be finding using law of sines are going to be acute angles, which means you do not have to worry about the ambiguous case. So it's not essential if you have a side that you start with the angle opposite the largest side, but it definitely makes your life easier, and the process is the same. And so that's it. So I encourage you to go back in 9.3 and 9.4. Heron's formula we didn't do. And look back through the example problems, make sure you can work through them, and if you can't, perhaps review the sections a bit more. Next time we're going to be looking at trig identities in 9.1 and 9.2. So until then, stay healthy and stay busy. I'll see you soon.